Hello everyone, and welcome back to the AI Research Roundup. I'm your host, Alex. It's May 3rd, 2025, and today we're looking at an interesting ICLR conference paper published just over 3 months ago, back on January 22nd. It's called Linear Representations of Political Perspective Emerge in Large Language Models. Alright, so this paper investigates if LLMs develop linear representations of political ideology, like the liberal-conservative axis, within their internal workings, and if we can use this to monitor or steer their output. Okay, so to illustrate this, Figure 1 shows some text generated by one of the models, Mistral 7b, discussing immigration and abortion. You can see tokens highlighted. More blue means the probe predicted a more liberal perspective for that token, while more red indicates a predicted conservative perspective. This uses one of the highly predictive attention heads found earlier, demonstrating how these probes can detect political slant even within open-ended text generation. Building on that idea of predictive heads, Figure 2 gives us a broader look across the models. Okay, these heat maps show the predictive performance, the Spearman correlation, for linear probes trying to predict lawmaker ideology. This is shown for all attention heads across all layers in Llama-2, Mistral, and Vicuna. Darker blue means stronger prediction. You can see the most predictive heads really cluster in the middle layers, roughly layers 10 to 20. Alright, so Figure 3 really visualizes the predictive power we saw in those heat maps. Plot A shows the actual versus predicted ideology for U.S. lawmakers, using an ensemble of the top 32 heads from Llama-2. You see a strong correlation, 0.870. Then Plot B shows these same probes predicting news outlet slant quite well too, achieving a correlation of 0.798. This really highlights the generalizability of this learned political representation across different domains. Okay, so now that we know these probes generalize, Figure 4 demonstrates how they can actually steer the model's output. Plot A shows the measured political slant of generated text based on the intervention strength, called alpha. You can see increasing alpha reliably shifts the text towards a more conservative stance, with significant positive correlations for all models. Plot B confirms the steering effect works across various policy issues, although some topics respond more strongly. Okay, digging a bit deeper into the nature of this representation, Figure A3 from the appendix provides more evidence for its linearity. It shows how well linear probes predict the original DW nominate scores versus various nonlinear transformations of those scores. You can see in Plot A the prediction is strong for the original linear scores, but significantly degrades for nonlinear versions like Schein or cubic transformations in plots C and D. This really supports the main finding. The representation is fundamentally linear. Following up on that linearity point, Figure A4, again from the appendix, lays out the whole intervention workflow. Okay, Part A shows the probing phase. They prompt the LLM to simulate politicians, grab the activations, and then train linear probes to predict ideology scores. This finds that political direction vector. Then Part B shows the intervention, using that learned vector to modify activations during generation, steering the output, which is then evaluated. It really illustrates the core method. So, wrapping up, that workflow really underpins the main finding here. It seems clear that these large language models develop a high-level, linear, and importantly, generalizable representation of political ideology. Okay, and leveraging these interpretability techniques lets us not only see this representation, but also actively steer the model's output. Well, that's all for this week's AI Research Roundup. Thanks for tuning in.